Right. Don't know if the link has changed. I think I might have worked out what the issue was with that sound. Let's see if people are going to come back. Bam, copy, link, location. I don't know if it's a different location now or. There we go. There we go, and there we go. Right. That sound thing is kind of weird. I don't think it's anything to do with the mic. I think it was some additional sound being picked up on a different capture thing. I had a listen. I had a listen and went back. I mean, it wasn't even that bad. You guys were making out like it was the worst sound in the world, but it really wasn't. I mean, just turn your volume down a bit. Anyway, let me know if it persists. All right. I feel bad about cancelling the stream. Cool. So anyway, what, you're getting the buzz now, are you, or? Yeah, I mean, it's just something you're going to have to deal with. All right. Okay. Anyway. So far we have created a we've created a black screen. I mean, so far so rubbish, right? It's hardly a game at the moment. And to make matters worse, we can't even quit out of it. So I'll tell you what, the first thing that we'll do is we will add in that quit out functionality. Okay, so the way that this is going to work is, at the moment we've got this infinite loop. What our code is doing is, to start off with, we're initializing Pygame. We are then setting up a screen surface that we're going to display things to. And we're setting the resolution of that screen to 800 by 600. We're setting the caption of said screen to bust out. And then we've got this infinite loop, which is just eternally updating the screen. Okay, so it's just redrawing the screen as fast as it can over and over and over again. Okay, what we want to do is, every time it updates, we want to say, is the user trying to quit? And if the user is trying to quit, we want to obviously exit the game. If the user's not trying to quit, then we want to carry on doing it. Now, Pygame has a way of handling that. It has something called the event queue. Now, the event queue is basically everything that you do is registered as an event. All of the different inputs, moving the mouse, clicking the mouse button, typing on the keys, sending termination signals to the window, for instance, by clicking on the cross, or by pressing Alt F4 or whatever your kill signal is set to. All of those things register as events. Okay, so think back to the stuff that we did on event-driven programming with the buttons and stuff tied to event handlers, dispatchers, callbacks. It's the same sort of thing here. Okay. So what we need to do is, first of all, we don't want this loop to be infinite. We want to have some sort of condition whereby it's going to end. So we're going to set up a boolean called game running. And that's not how you spell it. And we're going to set it to true. Okay. Now, instead of saying while true here, we're going to say while game running. Okay. So at the moment, we haven't really changed much. We want to have, however, something in here which is going to continually check to see if the user has quit. Okay, so in order to do that, we need to get a list of all of the events that have happened since the all of the events that have happened since the last time that we checked the events. Okay, my screen is not frozen, at least not on my screen here. So I don't know. You guys might need to check your internet connections or something. I don't know. Oh wait, I see what you're saying. No, my screen is not frozen. Wait a minute. No, you're right. That's very odd. Okay, bear with me 1 minute. I told you it wasn't going to be my day today. No, that still hasn't updated. Right, give me a second here. Let me try and fix this. Right. Let's see if that... There we go, that's working, right? Is that working? Excellent, right. Good. Right, here we go. So, what we want to do is we want to get a list of all of the events that have happened. Okay, so we're going to say for event in pygame.event.get. Right, what this does is it gets a list of all of the events that have happened since the last time we asked for this list of events. Okay. Now, we only care, at this point, we only care if the event is a quit event. Okay, so we're going to say if event.type equals quit, all in capital letters. Now, that quit is one of these locals that we imported. Okay, if we hadn't imported the local variable names there, we wouldn't have been able to do that. That's why we have this from pygame.locals import star. Quit is tied to a specific value. Okay, so if event.type equals quit, we want to set game running to false. Okay, and so if now the game registers a quit command, like either by clicking on the X in the corner, by pressing Alt F4, or by sending any other kind of kill command, it should set game running to false, and then after it's done all of this, it will just exit that loop. Okay. If we run that now, you can see there is my my window. If I'm running Linux and my kill command is set up to Windows Shift C, but I press that and it exits cleanly. Right, we don't get that that horrible message. Okay, so you should now have a game that you can run. It draws a black screen and then you can quit. What an amazing game. Okay. Good, but we want to do something a little bit. Yeah, we want to do something a little bit more, and maybe as well. We don't want to be total edgelords. We don't want a black screen. Okay, this isn't Sisters of Mercy here. We want something nice and bright. We want to fill the screen with white. Okay, what we can do is display surf. Remember, display surf is a handle to our screen, so we can say display surf dot fill, and then we specify a color. I'm specifying a color by giving 3 numbers. Can you tell me what those 3 numbers represent? If I now show you this screen. Nope. Where is the thing? Move that out of the way. There we go. Yeah, they are RGB values. They go from 0 to 255, which means you should now, if you want to, you should be able to change your the color to whatever you want. Let's say we want a very red screen here. We just change it to 25500. When I run that now, I get a very red screen. And that is making me angry and hurting my eyes, so I'm going to turn that off. I'm just going to set that back to white there. Okay. Yes, I am assuming some knowledge of programming already. I'm just testing that knowledge. Right. So so far we've got a kind of a rubbish program at the moment, and it's not just rubbish because of the stuff that it does, but it's rubbish because of the way that it's coded. Okay. At the moment, we're setting these the screen width and the screen height to these magical values. What if we want to be able to change them? We should really hold them in some sort of variable or constant. So I'm going to define them at the top here. I'm going to call them screen width. My screen width is 800, and my screen height is 600. Okay, and that means that if I ever need to worry about like what the screen width and the screen height are, I don't have to try and remember these numbers. I can just use these values. Okay, so no, I want screen width there. It also means if I want to change them, I can just change them at the top here. Okay. Yeah, I'm just going to carry on. I don't care about the buzzing, because having listened to it, it's a really minor issue. So you're just going to have to deal with it. I think I know what it might be, actually. My phone is next to the my microphone cable. If I try moving my phone over here, let's see if that fixes the issue. Anyway. So I've defined screen width and I've defined screen height here, and I've put them in here. I could potentially, if I wanted to, define some colors as well. For instance, I could say white equals 255, 255, 255, like that. And then instead of doing that, I could do this. Okay, I mean, this is known as syntactic sugar. It sweetens your variables and makes them, or it sweetens your values and makes them easier to understand. Okay. So anyway, where are we at now? We've got a white screen. Brilliant. We want to actually get something displayed on that screen, right? We want to create a sprite and display said sprite on the screen. Okay, and in order to do that, we are going to create a new class. Okay, so we are going to say class sprite. Remember, in Python, the naming convention is that classes are written in camel case, capital letter at the start. And we are going to first of all define the constructor. This is the method that is run when the class is first instantiated. Self is always the first item in there. We are going to pass two values to it. We need to know what surface it's going to be drawn on, and we also need to know what the image we are going to use for this sprite is. So it's basically where are you going to draw it and what's it going to look like. Okay, so when we instantiate this class, we're going to pass two things. We're going to pass the surface that it needs to be drawn on, and we're going to pass a location of an image that we're going to load. Okay, so we're going to set up the surface. Self.surface equals surface. Self.image equals pygame dot display dot pygame dot image pygame dot image dot load, and we are just passing the address of the image there, which we are going to pass as a string. Now there's something else that we need to know. We need to keep track of the position of the sprite on the screen, and we need to be able to change that position. And in Pygame, whenever you have an image that you're drawing on the screen, there is a bounding rectangle that goes around it, which is called the rect of the image, which stores various different bits of information which we can use to manipulate the image. And in order to do that, we are going to use everyone's favorite command. We're going to say self.rect equals self.image.getRect. Okay, everyone loves this. Self.image.getRect. Sad times. /wrists. So what have we got here? We are setting up our sprite. We're setting up the surface that it's going to draw to. We're loading in the image, and we're setting up the bounding box so that we can move it around. The sprite also needs a couple of other methods. It needs to be able to draw itself on the screen. Well, that's fairly straightforward. Okay, so we're going to say def draw. It's just going to take self as an argument. We are going to say self.surface. Now, every surface has a command called blit. Okay, and the way that it works is you specify the image that you want to draw on that surface, and then you specify the location where you want to draw the image. Now, if you've got a rect, you can just say, here's the rect, draw it in that rect. Okay, so we have our own rect. So to draw the sprite on the screen is going to be pretty straightforward. We're going to say self.surface.blit, self.image, because that is the image that we are going to draw, and then the position is going to be self.rect. I can type, I promise I can type. Okay, that's all there is to the draw function. I think we're ready to test this out now. Okay, so in order to get our sprite up and running, we need to instantiate it, so we need to create a new sprite. We'll start off with the ball. Okay, we're going to say ball equals sprite, and we are going to pass a surface. The surface that we want to draw it on is going to be the screen, which is called display surf. And the image that we want it to be is graphics/ball.png. Don't forget to put the quote marks around this, and also don't forget to that the image location is case sensitive. Obviously, if you've stored your images in a different location, give that different location. So this will create a ball. Okay, it'll create a sprite called ball, and then every time we update the screen, we are going to fill the screen with white, and then we are going to draw the ball on the screen. Okay, ball.draw. Does that make sense? If I run that code now, this is what we get. You can see my ball is drawn right in the top left corner of the of the screen there. Yes, thanks for pointing out my PEP8 error there. Okay, so we should, in theory now, we should have a game which all it does at the moment is draw a ball on the screen. Is there anyone currently watching who does not have that working, or if there's running into errors or anything like that? I can't see the ball. If you can't see the ball, double check that you are drawing the ball after you have filled the display surface, but before you have updated the surface. Okay, remember, this stuff happens in order. So if you draw the ball and then fill the surface with white, then it will paint over the top of your ball, right? Yeah, and make sure you update the display. Okay, so obviously this is intended for A-level students, so I'm not going to go into too much detail about what's going on with this whole class thing, but just as a quick recap, a class is an object about which we store bits of information. Okay, we store attributes, which are the properties, the variables that we can keep track of and change. And we store behaviors. Okay, these are the functions. So the great thing about doing this is that in theory I can create multiple balls, and I can have as many of them doing whatever I want without having to rewrite the code. I could, for instance, let's create another one. No, do you know what? I'm going to create a... No, before I do that, I'm going to set up a method where we can actually set the position of the sprite here. So you'll find that most classes will have lots of get and set methods. Set pos, we are going to say, we're going to take x and y as values, and this is what we're going to say. We are going to say self.rect.center. So this is setting the center point of our rect. Oh yeah, I put the phone next to the thing again. Sorry. Self.rect.center. Equals x comma y. So now I could create a second ball. Let's call it well, let's just call it second ball. Second ball equals sprite. I can even give it this same info here. Okay, so it's going to have the same graphic, it's going to be drawn on the same surface, but now I'm going to set its position. I'm going to say second ball dot set pos. It would help actually if I got the name of the function right. I'm going to set the position to, I don't know, 300 by 470 or something. Let's see where that ends up. Okay, obviously nothing's going to appear on the screen until I actually tell it to draw that ball. Second ball dot draw here. When I run the code, you can see now I have got two balls, which makes me better than Hitler. Yeah, see what I did there? See what I did there? Okay, so hopefully you can all see the advantage of using using classes here. I don't have to duplicate the code. I just have to say, oh yeah, here's another ball. Okay. Now, obviously, in our game of Breakout, we're only going to need a single ball. So I'm going to get rid of. It was Hitler's birthday yesterday. I mean, I would wish him a happy birthday, but I don't think he deserves it. So sad birthday, Adolf, if that is your real name. Okay. Cool. So here's the thing, though. Right, we've got a ball, and we can draw it on the screen. We're also going to need a bat. And the bat is going to be a sprite as well, but the ball and the bat are going to behave in subtly different ways. Okay, both of them need to be drawn on the screen. Both of them, you're probably going to need to be able to set their positions somehow. However, the way that they move is going to be fundamentally different. Okay, so those of you in my A-level group will remember, hopefully, we did something called inheritance. Those of you still watching, can you tell me what inheritance is? No one can explain. How rich kids get minted. Where there is one superclass which other classes can mimic. Yeah, so imagine this, yeah? We have a sprite, okay? If I create a second class that inherits from that sprite, it will be able to do everything the sprite can do. Plus some other stuff, right? Which I can add in there. Okay, so we're going to create a class for the ball here. Now, those of you that are not familiar with object-oriented programming and inheritance, don't worry too much. We'll cover this when you do A-level. So we are going to create a ball, and we're going to say that it inherits from sprite. If I could actually spell sprite. Okay, so the thing in brackets says we're creating a class called ball, and it's going to inherit all of this stuff from the sprite class. Okay, it still needs to have a constructor in it, and we're going to instantiate in the same way. So we're going to pass a surface, and we are going to pass an image. But first thing that we want to do, we want to set it up exactly like the parent class. We want to set it up just like the sprite, and then we're going to add some extra bits. Okay. So this is what we're going to do. We're going to say super dot init dot underscore underscore init underscore underscore and surface and image. Just by doing that, when we create a ball, it will set up all of this stuff that's in the sprite class for us. Okay. We're also, our ball is going to have something called a velocity. So we're going to say self.velocity equals, and that's going to be we'll set it off as nothing. Okay, it's going to be set there. And to start off with, I reckon the ball should start in the middle of the screen, so I can say self.setPos screen width divided by 2 and screen height also divided by 2. Notice it's not actually division, it's quotient there. That's integer division. We don't want, we can't have half a pixel, so we want to make sure that they are whole numbers. So that will set the position of our ball in the first place. Okay, now we don't need to redefine draw because that's going to be exactly the same. We don't need to redefine set pos. In fact, we've already used set pos, so there's no need to redefine that. But we are going to need a move function. Okay, so we're going to say def move. And the movement is going to be based entirely on the velocity. Okay, so the velocity of the ball is going to update the position of the ball. We are going to say x equals self.rect dot center 0 plus velocity 0. Sorry, self.velocity 0. Okay, and y is going to be self.rect.center 1 plus self.velocity 1. Okay, so what this is doing is it's finding out what our current x position is and adding on whatever our x velocity element is. It's finding out what our current y position is and it's adding on whatever our current y velocity is. And then we finally need to write that, so it's going to update our rect. So we're going to say self.rect.center equals x comma y. Okay, so moving is going to be handled by just updating based on the velocity. Okay, now to start off with, we're setting the velocity to be nothing, so we should probably have a function that allows us to set the velocity. So if we have a set velocity, we want an x and we want a y. We are just going to say self.velocity equals x comma y. Easy. We probably want to be able to get the velocity so we can find out how fast we're going, maybe. So let's have a get velocity method in here as well, and all that is going to do is return self.velocity. Okay. Boom. So there's a little bit more to the ball class than there is to the sprite class, but not a great deal more. One thing that I'm going to do down here, though, I'm going to change this so ball is not going to be a sprite anymore, it's going to be a ball. Now remember, ball inherits from sprite, so all balls are sprites anyway. So what are we going to do? We are going to, first of all, we want to set the velocity, the initial velocity to, I don't know, let's set it to, I don't know, 1 maybe. I don't know what that's going to look like. I don't know how fast this is going to run, but we want to get it. We want to get it moving. However, down here, we are going to not only draw the ball, we also want to move the ball. Okay, so we're going to say ball.move. Remember, we don't have to pass any information to that call because moving the ball is based entirely on the ball's velocity, and we've already set the ball's velocity there. So basically, every time Every time the screen updates, the ball is going to move one position higher on the x-axis and one position higher on the y-axis. Now, things to bear in mind: y starts at 0 at the top and gets increasingly bigger as you get down towards the bottom. And x starts off on the left-hand side. Okay, if I run it, let's have a look and see what happens. Oh, the ball just shoots off down the bottom straight away. We can slow that down, and we can make it bounce around. Okay, so the first thing that we're going to do is we'll make the ball bounce, and then I'll show you how you can get things like frame rate limiters in here. Okay, before I do that, do you all have something up and running with a ball that starts off in the middle of the screen and then just shoots off towards the bottom right and then disappears? No one knows. I know Alex got his working. Anyone else managed to get theirs working? Obviously, shoot any questions that you might have about any of this stuff at me. I think you missed something. Okay, are you getting an error message, or what's happening? I'll see if I can help you debug this. I appreciate that we're at the point where we're sort of like, there's multiple code. If you want, if it helps, I can copy and paste my code into the Discord for you, so you can have a look and see what's going on. Missed something in the main loop. There is the main loop. Okay. While you have a look at that, I am just going to go and powder my nose, and I will return in a couple of seconds. To help you out, I'm going to paste this code into Discord so you can have a look. Okay, so you should be able to verify any code that you got there. I'll be back in a couple of minutes, and then we will get that ball bouncing around the screen. My images aren't there for some reason. You've got to make sure that you have saved your images in the right location. If they're not in the folder, you've probably downloaded them and saved them somewhere else. You should be able to just copy and paste them in. That's something that I can't help you with. So I'm looking at my A-level students. I don't know how far along you are. Amy, if you have downloaded the thing. Owen, if you've got this working. Gabe, if this is making sense, let me know. Okay. Right, we are going to We are going to, still can't get Pycharm to cooperate. Okay, if it's still giving you jip, I can help you out later on. But feel free to sort of like follow along and make some notes as you go. Cool. So what we're going to do now is we are going to modify the move function so that the ball bounces when it hits the edge of the screen. Okay. So at the moment, all our move does is it will increase x according to whatever the x velocity is, and it will increase y according to whatever the y velocity is. We want to stop that if it reaches the edge of the screen. Okay, now that's fairly easy to do to start off with. There's a few things. There's a few things that we might have to come back and change. But for now, we know if x is less than 0, it means it's off the left-hand side of the screen. If x is greater than whatever the screen width is, it's off the right-hand side of the screen, right? So we need to make sure that x is in between those two values. If x is not in between 0 and screen width, then we want to make the ball bounce. And the way we make the ball bounce is by inverting the x velocity. Okay, so we can have an if statement in here. We can say, well, there's a number of ways that we can do it. We could say if x is less than 0 or x is greater than screen width, not screen height. Okay, that's one way of doing it. Don't mean to do that. Obviously, we then want to invert the velocity. It's easy enough to invert the velocity. We just say self.velocity self.velocity 0 times equals -1. That's going to multiply the velocity by -1. It's just going to do a straight bounce there. So that's one way of doing it. Another way of doing it, which I will show you on the Y here, which might make more or less sense depending on how you perceive things. You can say if not 0 0 is less than y is less than screen width. Both of these lines effectively amount to the same thing. It's up to you how you do it. Some people will find this terminology a little bit easier to understand. Some people will find this a little bit easier to understand. I find that mathematicians tend to go for this sort of thing, whereas programmers tend to go for this sort of thing. But I don't know. But the same deal applies here. We're going to say self.velocity 1 times equals -1. Okay, and that is going to make it bounce. Okay, so now when I run my program, I should get my ball bouncing around the screen. I've messed up though. It's bouncing, but I've messed something up here. Can you spot the semi-deliberate error that I have made? Okay, this stuff's working fine. The X bit is working fine. The error is in here somewhere. Can you spot the error there? Yes, well spotted. Should be screen height there and not screen width. If I just change that to screen height, when I run my code now, I get this wonderful bouncing ball. Okay. bouncy, bouncy, bounce, bounce. Okay, now at the moment our code is running literally as fast as the computer can handle it. What we probably want to do is slow it down, limit the frame rate somewhat. Okay, do you know what I'm going to do before I do that though? I'm going to say if I'm going to change this to if y is less than 0 or y is greater than screen height, just so that we've got some consistency there. Yeah, the ball's pretty happy. What we're going to do here, we are going to create a clock. Okay, we're going to make that clock tick, and we're going to try and maintain a frame rate of 60 frames per second, because this is a PC game, not a console game. Okay, so FPS clock equals pygame.time.clock with a capital C, open brackets, close brackets. What that does is it sets up a clock. We're also going to have a variable called FPS, which we're going to set to 60. Okay? So that's me setting them up right at the very start, and then right near the very end we are going to add something which is going to maintain that. Have we all got that? FPS clock equals pygame.time.clock with a capital C, and we're setting FPS equals 60. I am freezing cold. I don't know why it's so damn cold when the sun's out like that. I'm really cold. Is anyone else cold? Maybe I'm dying. I don't know. So once you've added that, once you've set up your FPS clock and you've set the FPS, tied that to a value, all you need to do is, after updating the screen, we are going to make the clock tick, right? So we're going to say FPS clock dot tick, and then the value that we pass is FPS. Okay, so what this command does is says, you know that clock that we set up, right? Make it tick in order to try and maintain a frame rate of whatever this value is that we've passed to it. We set the frame rate to 60, so it's going to try and maintain a frame rate of 60 frames per second. Okay, if I run that now, we can see the ball is now moving a lot slower, but we've got a nice 60 frames per second frame rate, and it's going to try and maintain that frame rate regardless of the hardware that we're running it on. Okay, that gives us a little bit more control. You can experiment with different values if you wanted to know what that amazing game would look like on a console, for instance. You could set the frames per second to 30, and you can see now it's way worse or something. I don't know. So obviously, now that we've got the frame rate limiter in there, we'll probably want to change the velocity. As Amy said, the ball looks kind of sad. It's a little bit worn out. I'm going to set the FPS clock to 60 frames per second, but I am just going to change the velocity. At the moment, our velocity is 1, 1. That means it's moving 1 pixel per frame. Okay, so it's only moving 60 pixels a second. We want to... If I put 10 in there, let's see. That's going to go reasonably fast, I would have thought. Yay! Okay. Lot nicer. Bouncy, bouncy ball. Okay. Amazing. Is that amazing? I think it's reasonably amazing. Yeah. And I know what you're all thinking at the moment. You're thinking, for God's sake, sir, you said this was going to be a game. At the moment, it's not a game. It's an animation. Okay. Yes, it is an animation. But how would you like to add some interactivity to this game? Yeah, I mean, you could, instead of it would be very easy to turn this into the DVD screensaver. All you'd have to do is change the sprite that you apply to the ball, and off you go. So there you go. Right, so we've got a ball, and we've made it bounce around. Okay, I mean, I'm still going to hold my hands up and say this is not perfect code. There's a lot of dodgy programming in here, but I'm sort of like, I'm building it as we go. We're going to go back and we're going to refine stuff. Eventually, all of this stuff here will be moved into its own class. We'll have a game class to handle that. Okay, so let's create a bat. Now, a bat is going to be a sprite, but it's going to have its own sort of like way of moving around, because the bat itself, it's never going to change its Y position. It's going to be fixed. But it is going to want to change its X position. It's going to want to change its X position based on the mouse position. So what we're going to do to start off with is create a bat class. Okay, so bat, it's still going to inherit from sprite. Okay, we want it to be able to do all of the things that sprite does. And to start off with, we have to initialize it, just like before. And we need to pass a surface, self, and we need to pass an image, and we need to call the initialization class from the initialization method from the superclass. There we go. But we're going to we need to set its Y position. So we're going to call that self.y, and that is going to be well, we want it to be however high our bat image is. We want it to be like just above that off the bottom of the screen. Right now, we could have a look and find out how many pixels tall the bat is. I know it's 20 pixels, but if we wanted to change that graphic, we wouldn't want to have to recalculate that. So we can get the system to do that for us, right? So self.y is going to be screen height minus self.rect dot height. Yeah, and that's that. Okay. Remember I said the rect contains a whole bunch of information. We've been using it to set the center point, but it also contains the width. It contains the height of the stuff as well. Again, an attribute error. Can you give me more information? Good. We are now going to overwrite the setPos function. We only need to know the x value. Okay. We're going to say self.rect.center equals whatever x is, self.y. That self.y is always going to be the same. Okay. Do we need anything else? You know what? I don't think the bat needs anything else, because the sprite class already has draw and it already has setPos. Okay. Ball.set velocity. Without seeing the rest of your code, Sol, I wouldn't be able to debug that. But if you're getting an attribute error, do you definitely have a set velocity function? Is it set up like that? I don't know. I need more information to help you debug that. Okay, so we've got our bat, and we've got this set position for the bat. Let's create the bat here. So bat equals bat. Whoa, what are you doing? Don't need that. Oh, did not mean to do that. Right, bear with me one sec. Accidentally closed down Pycharm. Let's get that. Let's get that back. Do 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 do. Right, there we go. Bat equals bat. We are going to pass the display surf, and we are going to tell it to load graphics bat.png. We'll set the initial position of the bat to be in the middle of the screen. So we're going to say bat.setPos. Remember, we only need to pass an x value to it. So we can say screen width divided by 2. And I'm using integer division again. One thing that we need to remember to do as well, with drawing the ball, we also need to draw the bat as well. Okay, if I run that code now, we should still have our bouncing ball, but now we also have a bat down the bottom there. Okay, it's positioned in the middle, in the middle of the screen, and it is set near the bottom. There's a little bit of a gap in there. The gap is in fact half the height of the sprite that we're using there. Okay. There's no collision yet. Let's not get ahead of ourselves. We'll get there though. Don't worry. Okay, 2 errors. I can help you out with those errors as long as I know what those errors are. But it might be just a case of reading the code, making sure that you've got everything the way that it needs to look. So self.velocity 1 times equals -1. Tuple object does not support item assignment. That implies that in your ball class here you've set self velocity equals and then you've used normal brackets instead of square brackets. So just double check that, make sure that you are using square brackets for your velocity, because you will not be able to change them otherwise. Also, you might want to double check that your set velocity also uses square brackets there as well. Okay. I'll put the code up in the Discord in a moment. First of all, though, I want to get the interactivity going, because we've got our bat there, right? We're drawing the bat on the screen, but we need it to actually do something when we move the mouse. Okay, and that brings us back to this. This was the loop that we wrote right at the very start that was constantly checking to see what the user had done. Now, at the moment, the only thing that we're checking for is whether they've quit or not. But we can also check to see if they've moved the mouse. If they've moved the mouse, what we want to do is update the position of the bat based on the position of the mouse. Okay, so we're going to make a slight modification here. We're going to say if event dot type equals mouse motion. What do we want to do? We want to set the position of the bat. We're going to say bat.setPos, and the only thing that we need to pass to it is the position of the mouse, the X position of the mouse, and that is easily got if you go pygame.mouse dot get pos. Now get pos returns a I believe it's a tuple, which contains obviously the X component and the Y component. So we just want the first component there. Okay. So what that's going to do, in theory, is set the position of the bat to be wherever the mouse is on the screen. So if I run that now, you can see I have my bat moving around with the mouse, okay, while the ball bounces around, completely ignoring whatever is going on there. Okay, so I will, as requested, paste all of this code into Discord so you can double check. There we go. I've just updated the. I'm just going to update the other post here. So there's that, and let's edit this one here. Ba-bam. Okay, so far, what have we got? We've got a ball that bounces around the screen. We've got a bat that moves based on the position of the mouse. What do we need now? We need to make the ball crash and reset after it goes off the bottom of the screen. We also need to check to see if there's a collision with the bat, and yeah, that's about it. Well, obviously we need to add like blocks and stuff like that. Okay, so what's the current time? It's 12:48. Wow, we've been going a while. I think the next thing to do, I don't like all of this stuff down here and all of this just hanging around in the global scope. So what I'm going to do is create a game class which is going to handle that. So we'll have the sprite class, the ball class, and the bat class that inherit from it, and then we're going to have a game class which is going to handle the setting up of the game and the running of everything. And then checking collisions, that's going to be part of the game class. Okay, so what the game's going to do is going to say, right, where's the ball right now? And then it's going to say, where's the bat right now? Okay, and then it's going to say, well, are they colliding at the moment? Because if they are, we want the ball to bounce, and if they're not, then the ball can just carry on doing its thing. Okay, so that's what we're sort of like aiming towards. Whether we will get that done or not is another matter. Okay, but before I move on, does anyone have any questions or bugs with their code that they want me to help them try and fix before I move on to that bit? Do you know what? I'm gonna while you think about that and answer that question, I'm just gonna go and get a jumper to put on because I'm so cold. I don't know why I'm so cold. I will return shortly. Found a jumper. glad you're still here, Blessed. And I hope everything's going well in your life. It's good to see you. Alex, less of that. Blessed is one of my old Year 11 students who was totally awesome. So yeah. Okay, are we ready to sort of like pull together a game class here? Does that sound like a cool thing to do? Okay, right. So we want to have class game. Now the game is basically going to handle all of the stuff that has just been floating around in the global scope. Does it need anything to get going? No, it doesn't. So let's have a look. At the moment we've got this stuff here. I'm going to keep that as it is, but what I am going to do is this lot here, I'm going to move that into the game class. So going to cut that out from there, and that is going in here. Okay, so instead of display surf like that, what we're going to do is we're going to say self dot surface like that. Now that does mean having to update a couple of things, but we will cross that bridge when we come to it. So we're still setting that up, and we are still setting up the caption there. We're also going to set up our ball, but it's now going to be a member of the main, the game class. So it's going to be self.ball. And we're going to set up our bat as well. Okay, I'm just reorganizing some of this stuff. Instead of display surf, we're going to have self.surface here, and instead of display surf there, we're going to have self.surface, and that's going to be self.bat. I'm not actually going to put the set velocity and set pos into the init, I don't think. I'm going to set that up though. Right, okay, so here's our initialization. We are going to have a function called start game. Let's start that off as false. Start game, that is going to set up the initial velocity of the ball, the initial position of the bat. Did we set up the initial position of the ball as well? I don't know. We should do though. So let's do self.ball dot set pos. That is going to be screen width divided by 2, screen height divided by 2. that sets that up, and I'm going to change the name of start game to reset game. Yeah. We're going to have process game, and that is going to do all of this stuff here. So when we process the game, we're going to move the ball, we're going to draw the ball, we are going to also draw the bat, but we are going to also check events, and in order to do that I'm going to need a check events function. And that is going to have our event handler in it. Okay, right, we're getting there, let's have a function called run. So run is going to first of all reset the game. Then it is going to say while self.running, and while it is running, we are going to do self.surface .fill white, and then we are going to do self.process game, and then we are going to do a Pygame .display .update, and I'm aware that I've spelt Pygame wrong there. And then we're going to do the FPS clock .tick. And we can get rid of that. Right. So this is our game class. It's fairly large when you look at it, but it's structured in such a way that if we wanted to add additional functionality to the game, we can easily do that. Like, for instance, obviously, when we process the game, we check for any events, then we move the ball, then we draw the ball, then we draw the bat. Okay. If we are going to add collision detection, we just create a new function called check collisions or something like that, and we add it to the process game queue. Okay. Run will reset the game. It will then should set self.running to true, and then I keep seeing some shadows. Oh, it's someone cleaning his car out there. We set self.running to true, and then it enters this game loop, and it's going to keep on doing that until something happens that sets self running to false, i.e. the quit thing happening there. Okay. Now, if I run my code now, nothing's going to happen. You can see there it just exits because I've moved everything into the game class. I haven't actually instantiated the game class or told it to run. All right, so we are going to say here game equals game, and then we're just going to say game.run, and in theory we should now be back to where we were, but everything is now nicely encapsulated. Okay, so at the moment we have a number of classes. We've got our sprite class, and then inheriting from the sprite class we've got the ball class and the bat class, and then we've got the game class, which is the thing which is controlling the bat and the ball. Alright, I will update the version on Discord to be this whole shebang here. I can't update Discord because there's too many characters. What I will do is I will just upload the file. Bear with me 1 second. Where is the file? There we go. That's that one, and that's that one, and that's that one. Okay, so I've uploaded the code to all of that lot there. I'll also put links in the description for the code and for the images. We've been at this for a long while. What I'd like you to do now, okay, I'm not going to get into the ins and outs of checking collisions right now. What I'd like you to do is, with that code, I'd like you to go through and just add some comments explaining what's going on. Okay, so you should be able to understand what's happening here. Add some comments, right? If you reach a section in the code where you don't know what it's doing, then you have a question to ask me so that I can explain it. Okay, I want you to go through and add comments just explaining what that code means, just so that you know which bits you don't understand. Okay, trace the flow of the program if necessary. Right, what I would do if going through this, I'd think, right, we're importing Pygame, we're importing the locals from Pygame, we're initializing Pygame, we're setting up all of these global constant values which are going to be used throughout the program. Okay, we define a sprite, we define a ball, we define a bat, we define a game. We don't actually go into any of that bit at the moment. Here is the first thing that we're going to do. We're setting up an instance of the game class. So therefore we go into the game class, we look at the constructor of the game class. Does that make sense? Yeah. and then we're calling the run function of the game class. Right, what happens here? We're resetting the game, we're setting self-running equals true, blah, 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 blah. Okay, so you can then go and you can then go through and comment the code. And any questions that you have, bits about the code that you do not understand, I want you to ask me those questions. Okay. Next lesson, we will look at getting collisions working, and then we'll look at adding some blocks, and maybe we'll look at keeping track of score and stuff like that. But I think we've covered an awful lot in the last couple of hours that we've been at it. I want to give you guys some time to just go through and have a look through. Just before I go, though, does anyone have any questions about any of the code that we've looked at? Are there any bits that you're not sure what's going on? Any bits that I sort of skipped over? Is there any bits that you don't get what's going on there? What do you mean, when am I coming back? This is the end of this stream. Yeah, there will be additional lessons. Why don't you use a big main function and use the if statement thing to call it? Well, I mean, I could do, or it would look like this. There. Is that what you're after, yeah? Same deal. Okay. But I mean, that's not strictly necessary. The important thing is keeping as much stuff as possible out of the global scope, and having individual classes to handle that stuff. I mean, global constants, they're fine. Global variables, bad news. And also, if you've got a whole ton of stuff going on here, you should probably look at ways to make that a little bit more concise. For those of you that are wondering what this nonsense here is, basically what this means is this stuff will only get run if the program is being run as a program. It means that if I imported that program as a module, this stuff wouldn't get run, but I'd then have access to all of the classes that are in there. Okay, so that's basically what that. As I said, not strictly necessary if you're just working on a single file solution, but it's there like that. Cool. Well, there doesn't seem to be any other questions, so if it's all the same to you guys, I am going to disappear and make something to eat. I will be around in Discord if you have questions that you need answered on this subject or anything else. If there's bits about object-oriented programming or inheritance or anything that I've used in here, which is sort of because I'm very aware of the fact that I just sort of launched into writing these classes as if they all made sense. So don't be afraid to ask me questions about that stuff. Okay. Between now and next lesson, what you can work on It's making sure that this is all up and running, making sure that you've got those comments in there explaining everything that's going on. But also, if you wanted a challenge, you could try creating a function called check collisions, which is going to check to see if the bat and the ball are overlapping, and if they are, to invert the y velocity of the ball. Okay, that's what we're going to do next lesson. But if you've got some ideas on how that might work, then by all means, don't wait for me. Get them in there. All right. Thank you very much for your time, everybody, and I shall see you whenever I see you next. Wait. What am I waiting for? Yes, we can put that functionality in there, but to start off with, we're just going to worry about the y velocity. We're going to keep it simple to start off with, and then we'll add the extra functionality. All right, thank you very much, everybody.